Testing 1, 2. There's sound. Happy Groundhog's Day. So hopefully we have sound now. I didn't check it before I started. So let me start over. This is RockSim Live. I'm Tim Van Milligan. Today is February 2nd, 2024. It is Groundhog's Day. I don't even know what that means, but we've always celebrated it as little kids, where the groundhog comes out of the hole. If it sees its shadow, or if it doesn't see its shadow, it doesn't, it means early spring or late spring. But my groundhog right here came out with a rocket, and he's saying it's rocket flying season. I generated this image here in Google Bard, which has a brand new image generator. So I just had to try it out, see if it worked. So that's the groundhog. So we have a bunch of people here already. We have Jeff Gortowski, Terry Wheelock, Chris's Rocketry and More, and Johan de Sloper from the Netherlands. Hey, glad that you could be with us today. While it is Groundhog's Day today, we are going to have a snowstorm tomorrow. So that's going to be so much fun. I'm plugging in. I just downloaded the beta version of Roxim Pro. And while I was here, maybe I'd play with the beta version. We'll see. Depends on your questions. So if you have questions on how to use Roxim Pro, or the Launch Visualizer, go ahead and put those in the comments. And that's our purpose here, is to answer your questions. I'm trying here to make you a better modeler, so your rockets fly higher, they fly straighter, they fly safer, you get more enjoyment out of the hobby, and have a good time. So give me your questions, pour them in. I got a monitor over here that I'm looking at, seeing if there's any questions coming in. Let me switch screens. Let me make sure I got the microphone. Okay, we got the microphone working here. We got Carlos here, and he says it's 69 degrees in Marietta, Georgia. And Carlos, I hate you. I'm just jealous. We got a nice warm day today too, but it's not 69 degrees. And I said it's going to snow tomorrow. Okay, so what we got going on here is this, oops, wrong screen. I clicked on something. I wanted to first talk about the Apogee website. So if you're brand new and you've never heard about RockSim before, you get it at apogeerockets.com. So you come to our website and you can see this banner right here. It says RockSim 10, and if you click on it, it will take you to a place where you can download a free trial version right there, both Windows and Mac. If you're ready to buy it, you can order right there. If you have an older version, you can upgrade right there. If you go back to the home page, if you scroll down just a little bit, we have the free RockSim training every week. We call it RockSim Live, and that's what we're doing right now. This is where we answer your questions about RockSim. And if you click on this image here, it will take you to the archive page where we have all of our previous episodes. Last week, we did not have an episode because we had NARCON. That was the National Association of Rocketry's annual convention. And it's a virtual convention, so it's all online, like on Zoom. And we were participating, and I'm sure a lot of you were watching that at the same time, because they did from Friday at lunchtime all the way to Sunday in the afternoon. I don't know how long it went. I did the manufacturer's forum on Friday night, and then I did a presentation on how to make carbon fiber airframes on Sunday morning. And if you missed it, you can only see it by going to the NARCON page and it's recorded so you can watch it again. And there's some recordings that I have to watch. So the previous episode was 153, and Martin did that one. That was on January 19th. I was out of town. So he talked about, he was talking about building a glider. I watched it when I got home, and I was just like, holy cow, this is great. So instead of being a RockSim tutorial, it was a tutorial on how to build a foam glider. So if you missed that episode, it's episode number 153, and here's the link on YouTube where you can start watching it. This is all great. No questions yet. We have 6527 Dave, and he's the first timer. Well, welcome, Dave. This is great to have you. Okay, so, going back to the website. If you want more information about RockSim, come here to the how-to and guides, click on that, then come down here to software. And again, this is where you can download the free trial. Here's where you can purchase. Here's some information, just a broad overview on what is RockSim. RockSim version 10 features, the frequently asked questions, system requirements. Basically, if you have anything like Windows 11 or Mac, on the Mac, it doesn't go back that far. You can only go back to 10.15 Catalina, and I think Catalina might not work anymore. I'm running I'm running Sonoma on my computer. Yeah, I have to check that just to make sure. And Roxim Pro runs on the same thing because it's just basically identical, except for it can do a little bit more. Also under how-to and guides, under software, you'll find video tutorials, the RockSim live training, which is what we're doing right now. Yeah, all kinds of good stuff. That's kind of where you find RockSim and what it's about. I'm still waiting for some questions, people. What are your questions about designing rockets? Here, let me bring up this front camera. While we're waiting, let me turn off my groundhog. This rocket is the Estes doorknob. I'm thinking Black Brant 12, which is a new kit that just Estes released not too long ago, and we finally got them in, but they're not on our website yet. But we also got in the Great Goblin, and that will be on our website on Tuesday. But in the meantime, one of the things that we've been doing is we've been designing a 3-inch. I don't know, I can't zoom the camera in, so you can only see it here. But in the bottom of the nose cone, if you cut off the back, you can put in an eBay. So this is a nose cone eBay kit. And that's what it looks like. It's a board where you mount all your electronics right here. On the back side is a loop, so you can attach your parachute and shock cord. On the inside of here, it's got a twist together locking mechanism. So then it's locked in. And as you can see, it does fit the Estes nose cones. So this is the doorknob, and this is the Big Red Max, I think it's called. It will fit that one too. That's also a 3-inch diameter nose cone. And it also fits the Apogee brand new 3-inch diameter nose cone. So let's go back here, open up the website again. Oops, wrong one. I opened up the wrong thing. Let's see, 3-inch eBay. There it is right there. So this is the 3-inch eBay kit, and it will fit into our kit the catalyst. It will also fit into the Chronos, and future 3-inch diameter kits from Apogee. The Catalyst was a kit that we just released. It's our last one. We just released it like 2 days at the towards the end of the year, like December 29. It was like, yeah, it was like very end of the year. So it's still a brand new kit to us. It's just barely a month old. So that's what it looks like. And this is what it looks like when it's flying. I think I flew it on an F motor on that one. That's how big it is. It's 3-inch diameter. Our nose cone is longer than the Estes ones. But it's just as fun. So, so if you're interested in doing electronics in a short rocket, and that's the purpose of the 3-inch eBay, is if you have a short rocket, you don't have a lot of room inside, so you want to, if you want to put electronics in it, that's pretty much the best place to put it, because there's a lot of room inside of a nose cone. Okay, Carlos says, are there tricks or automations simulate a series of smaller fin spans with the goal of the shortest safe span choice in a 6-mile-an-hour wind? That's a good question. There is no automation secrets. Let me tell you what he's talking about here. So let me open up a kit. Let's go with the Apogee Avon. Okay, so here's an Avon rocket. And so what he wants to do is to make these fins as small as possible and still have the rocket fly stable. So the reasons you might want to make it smaller is to reduce the drag and to reduce the weathercocking, which brings up a interesting observation. One of the sessions at Narcon by Tom Fetter, and I found this one fascinating. He did a study, and I think he used RockSim for this, where he basically, he was not so much changing the size of the fins to reduce drag, but to reduce the stability margin. So the stability margin is the distance between the center of gravity and the center of pressure. And this one seems like really far. Mass override. It doesn't have a rocket motor in it. So to load a rocket motor, you go here, choose an engine, and you can choose an engine, and I'll click OK. And then you can see that the center of gravity changes. Why is my center of gravity so far forward on this rocket? This just doesn't seem right. Nose cone. I got a mass object here. 50 grams! I put a big weight in this one. Yeah, so let's delete that. So this kind of brings up something that I was talking about earlier. New features that are coming in RockSim version 11. Right now, what you're buying and what you're using is RockSim version 10. Version 11 is really close to being released. We got some finishing touches we have to do, plus we got to update our website, and that's going to be a while. But I can start showing you some of the features. It's just I can't sell you this yet. And one of the new features is right here. You see how I was able to tell that this mass right here was 50 grams. Well, this feature of all the parts displaying their mass is not in RockSim 10. That's only in 11. So I'm going to delete that component. So if you're in version 11, which you're not, but in the future when you are, if you want to see that, you have to go to the preferences. So on Windows, it's under Edit. On the Macintosh, it's under the Apple menu. And just come down here to Preferences, and then go to the 2D drawing. No, not 2D drawing. It's under Units. and there's a little checkbox that says show masses in component tree. This right here on the left is your component tree. It shows you just all the components and how they're related to each other. So if I uncheck that and I click OK, that goes away. But if you want to see it, and I kind of think it's a good idea to see it, just so like, and what it's useful for is just like what I showed you, is you're looking at the rocket and something's not right. You know, in my case, the center of gravity was way too far forward, and I don't know why that was. So I know it had to be something either with a mass override or there was a component that was really heavy. And so I just scrolled down until I found that one that was like really far out of bounds compared to everything else. And immediately, just that fast, I knew that that's where the problem was. So that's one of the cool new features. But anyway, I lost my train of thought. So what Tom, I think it's Fetter, was doing was the distance between the center of gravity and the center of pressure will tell you the margin of stability. And this one is a margin of 1.12. And so what he did was ran simulations changing the margin of stability. And in his case, he was making it longer. So making this number greater, which means moving the center of gravity forward. And what he found was that by moving it forward, it really didn't affect the altitude of the rocket. Because even though it's going to weathercock into the wind, the amount it weathercocks compared to a rocket that has a margin of 1.0 is really not that great. So it's good to have a large stability margin. So don't think you have to make your stability margin of 1. And typically you can change that by either moving mass in the rocket or changing the size of your fins, which is the question that Carlos asked. How small can you make the fins? Because if you make them smaller, the center of pressure is going to move forward and your stability is going to go down. But RockSim does not have a feature to show you what's going to happen by changing it. You got to do it manually. You got to open the fin. You know, in this case, let me go into 2D. You know, if I change the semi-span, which is what he's talking about, you know, so right now it's at 1.9 inches. So that's 1.9 inches measured from the tube out to the tip. So if I make it smaller, like 1 inch, and hit the tab key, you see it got shorter. And the stability margin, as I said, is, you know, the center pressure is going to move forward because those fins are less effective. So here it's marginal, and he was saying, I think, a 6-mile-an-hour wind. Yeah, 6-mile-an-hour wind. There's so much involved here because this gets into dynamic stability. And it's just not static stability, which is what we're looking at here. This margin is the static stability margin. That means the rocket's not moving. But as soon as the rocket moves, things happen. Things get dynamic. It starts wiggling. It's, you know, the wind hits it. So it gets a little bit crazier. This is a better experiment in RockSim Pro because RockSim Pro is a 6 degrees of freedom simulator. So let me cancel that. And one of the things I was going to say was like, can we do this in RockSim Pro? And what I have done is I just downloaded the demo or the beta version of RockSim Pro, but it's not seeing my flash drive. Come on, flash drive. Oop, my flash drive is not, it's not plugged in. Gotta move cords around here. There it is. Okay, Roxim Pro. I'm gonna install it. So if you've never installed Roxim, this is how you install it. And just basically you double click on the installer. This is the file I downloaded from the internet. And it's thinking. There it goes. And do you want to allow this one? Say yes. And then it's going to go through, the agreement, accept, click next, create a desktop shortcut. I think I already have a desktop shortcut here. So I'm going to get rid of that and I'll leave Roxim Pro 3 there and then hit next and install. And this should take just a few seconds. There it goes. Okay, if you still have any questions, go ahead and put them in the chat. We got one from Johan. He says, this is Johan. He says, how much can you hammer barometric and acceleration sensors till they fail? Well, the accelerometers are G limited. You might get like a 50 G accelerometer, and if you go higher than that, basically it's kind of like there's a little weight in there, and it measures the deflection of a beam by it measures that deflection, and that's how it gets how much you're accelerating. If you accelerate faster than it can measure, basically you peg out your beam. The beam pegs out, and then you don't get any additional acceleration data. The accelerometer is still good. It's just you're moving too fast and it just can't read it. So once it starts slowing down again, the mass will go in the other direction, and then you start getting data again. Where do they fail? Probably at the point of impact. When you hit the ground so fast that it just crashes the entire rocket and shatters the electronics. And that probably goes for barometric sensors too, because they are so small that they have very little inertia. And so it's very hard to break them. You'll break everything around them first. You'll destroy the other electronics. The board will crack, the rocket will crack, things will go sliding into it. Yeah, so you can hammer them pretty hard. Troy Airmet says, how do you vent for the altimeter when it's mounted in the nose cone? Okay, so let me go back to this screen. Okay, so on this nose cone here, I forgot to put the eBay back in. You would typically make a hole right here. However, there's enough leakage around all the seals right here that you could, I got it in wrong. You could actually put the hole in the tube and the air would actually get into the nose cone. So you can do that. And I've done that on small rockets and it works fine. If you ever look at a barometric sensor, the actual sensor on the board, look how small the hole is that lets air into the sensor. It's just as small as a pin, probably smaller than a pinhead. So any hole in the rocket that's bigger than what's on the barometric sensor, that air is going to eventually get to that sensor and you're going to read the altimeter. Now, if you're using a barrel sensor and trying to get acceleration and altitude, then you basically have to do some math. And in that case, then you want to put your altimeter hole further back from the base of the nose cone. At least, I think it's, the rule of thumb is at least one body tube diameter. So this is 3 inches. So 3 inches back from the base of the nose cone, right there would be your hole. If your barrel sensor is trying to measure speed, but typically you don't use a barrel sensor for speed, you use an accelerometer for speed because that's much more accurate and much faster. And barrel sensors can be confused by the airflow over the rocket, and that's why you need to put your hole further back for a barrel sensor. For an accelerometer, you don't need a hole at all because it's just measuring acceleration, so it doesn't need any air pressure. So the only time you drill a hole is for a barrel sensor, a barometric sensor. Yeah, so but so when the rocket is going up, it goes up really fast, but as it gets closer to the top, it's slowing down. And that's why the size of the hole is really not that important, because it's moving so slow that there's a lot of time for the pressure inside the rocket to stabilize if you have a little vent hole or if you have air leaks in your tube. And we actually did a Peak of Flight newsletter that studied this phenomenon, and you can download it from our website. So let me go back to here. Okay, so our RockSim has now finished installing. So I can open up this, I can finish, and it put a new shortcut here on the desktop. And as soon as it opens, okay, so there it opened. Okay, so I'm going to show you another new feature. Okay, so when you first install RockSim or Roxim Pro, it always does this database merge. So it's looking for new parts because basically you just downloaded it from the internet, and it's got to put all the parts into the correct folders on your particular hard drive. So when you install it, say yes to all, and it just takes just a couple of seconds to load all the parts into the right spots. Now here's the new feature. This is the new feature in RockSim 11 and RockSim Pro. It's called Auto Engine Update, and this is the first time that I'm announcing this. Basically what happens is RockSim will look out on the internet at a website called thrustcurve.org, and it's going to look for all the motors that they store there. Thrustcurve.org is kind of like the repository of all the rocket motors made, and they have all the ones that are made that are NAR certified, AAA certified, Canadian Association of Rocketry certified, Australia certified. They got the Klima motors from Germany. Even old motors that are out of date and discontinued, they're all on their website. And so RockSim is looking on that website, and it's going to download them. It's just going to save you time, and basically it's going to keep your motor database up to date, so that you do not ever have to worry again about, do you have the newest motors that are available? So you click yes, and here's where it's going out to the internet, sending a search request. It found 1,114 motors, and now it's downloading them, and this doesn't take too long. And see, it's downloaded 1,114 motors, and the next update will occur 1 month, and will occur on February 3rd, tomorrow. Okay, so now my motors are updated. And that feature is again turned on in the preferences. So by default, it is turned on. So if you want to turn it off, go to preferences, and then go to the tab. There's a new tab called Auto Engine Update. And here it says it's turned on. So it's going to check, and it's going to check once a month. And you can select a day, week, month, 3 months, 6 months, or a year. By default, it's set up to month. If you want to force it to go out and look like right now, hit the engine update button now, and it will just like force it to go look. If you want to go back to the original settings with all the old motors, you can restore the engine defaults. When you install new motors, it's going to overwrite your engines that have the same file name. So like an E30 from Aerotech, when it downloads an E30 and you already had an E30 in your database, it's going to override it. If the motor names are not the same, like you might have an E30 and an E30T for, Blue Thunder. Now you're going to have two motors because they're different names, even though they are the exact same motor. So that's the downside of having automatic engine updates, is we don't control the names that are used on thrustcurve.org's website. So it's just going to see the new motors and download them. This is like the coolest feature, and it works that good. So I'm leaving that on. Okay. So I wanted to go back to Carlos's question, and we're going to open up the Avon. I want to go to the design folder, go to the Apogee components folder, go to the Avon, open the Avon rocket. Okay, so here's the Avon. And as we did before, let's first run a simulation. And I'm in Roxim Pro, and this is 6 degrees of freedom. So this does a little bit more than RockSim does. So we're going to load a rocket engine in here. I want to get a baseline simulation to see what it does. So I'm going to choose an engine, and I'm going to show you another little feature, brand new feature, is the search the engine code. So say you're looking for an Estes C6. So you can just type in C6, hit the tab key, and it shows you all the engines with the C6. So I can take the Estes C6 5, and I'll click OK, and that loaded it into the rocket. Under flight events, I'm going to say deploy at maximum ejection delay. And starting state, 36-inch launch rod, and it's pointed 3 degrees from vertical. Let's make it 0 degrees. We'll go straight up. The azimuth is a compass angle. Since we're launching straight up, it doesn't matter what my compass direction is because we're going up. Now, if I had an angle on it, then the compass direction means something. North is here at the top, east is at the right, south is down here, west is that way. But since I'm at 0 degrees, it doesn't matter. Under launch conditions, let's see if we can choose a launch site. Here's the Cloudbusters website. This is in my database. So this is in western Colorado. The wind table, Carlos said 6 miles an hour, so let's make it a 6 miles an hour wind. And this is coming out of the west. So 270 direction is west. So 0 degrees is north, 90 degrees would be east, south is 180, and 270 is from the west. So we're going to launch this rocket straight up, but there's a wind coming from the west that's going to hit our rocket. And then we want to see what it's going to do. So I'll hit the flight profile button, and this is, so it, I can see back here how high the rocket went. It went 783 feet. No, the maximum altitude is 784. All right, so there's my rocket sitting on the pad, and just kind of give you an overview of where we are. I'm zooming out, and so here's the United States. Whoop, I'm giving you a vertigo there. So the black arrow down here in the bottom left corner, that points to the north, and the rocket launch location, lost the rocket. So if you lose the rocket, what you do is you hit the home button, and that will take us, it will zoom in to where the rocket is. So there, it's going to be in this area somewhere. All right, there's the rocket sitting on the pad, but it moved north around again on us. And it's really hard to tweaky. Okay, so there's the rocket on the pad, and I'm going to give it a little bit of perspective. Okay, and then when we launch it, the rocket takes off. You can see it arced, and west is over here. If this is north straight up, so it arced into the wind, and now it's being blown back. And if I'll let it go all the way back down to the ground, so I'm just gonna, and then zoom out, and so we can see the trajectory here of the rocket. And what I want to show, so this is our baseline. I can't grab that. There we go. This is our baseline trajectory. And let me turn off some of these features here. So all these little dots, these dots are 1 second apart, and I don't really need to see those. So that is these dots right here, the trajectory path. Let's make it green. Green is a little easier to see. And we'll turn off the weathercocking cone. Okay, so here's the trajectory path. So the rocket launch point was right down here at the bottom. The rocket arced over, it went into the wind, it weathercocked into the wind, and it reached a peak altitude, what we said was right here, 784 feet. And then it started coming back down, and it landed over here. So that's the baseline. So now let's run a simulation and take the fins and make them shorter and see what it looks like. Okay, so let me look at it here. So I'm just kind of, when we make the fins smaller, one thing that's going to happen is the mass is going to decrease because we're cutting fin off and we're cutting material off. So I'm just going to kind of see how much mass we're losing when we cut the fins off. So I'm going to go to the rocket design components, and that will bring up the tree, and I'm looking for my fins, and right now they're 2.31 grams, and we'll make these 1 inch. So I'm going to cut off almost a full inch. Okay, so now we have that, and we lost, what did we say it was, 3.1? So we lost probably 2 grams of weight. So since we lost a little bit of weight, we expect the rocket to go a little bit higher. But this is the dynamic part of the rocket launch, because now it's dynamic, it's just not static. So I'm going to click OK, and I'm just going to run that simulation again. This time, the rocket did go higher from 784 feet to 842 feet. If we want to see what that flight profile looks like, we'll hit that flight profile button right here. And make this screen bigger. I don't think probably the flight profile changed too much. We were in the air longer. Before it was 40 seconds. Now we're at 43. And let me go back here, turn these off. These should not have turned back on. Okay, click OK. And this time I'm going to look at it from a trajectory view. Whoa, we lost our maps. Yeah, see, we lost our ground. And my programmers are actually working on this as I am playing with it. We lost the maps for about 2 days, and then all of a sudden they came back about an hour before our presentation right here, and now they lost them again. So I think they're still working on it. But we can still see the trajectory of the rocket. What happened there? We can still see the trajectory of the rocket when it takes off. So it took off, it arced into the wind, it's still going up, Okay, so there's where the parachute came out, and now it's going to descend back down to the ground. So the trajectory, it looks pretty similar. So I would say cutting, in this case, cutting some fin off, it was acceptable. Because the rocket didn't go unstable. At some point, if you cut the fins off enough, the rocket, oh, here's why it worked. Look at my center of gravity is way up there. Why is that? Well, because I still have that 50-gram mass there. Delete it? Yes. Okay, let's run it again. Oh, this one time it went a lot higher because it's 50 grams lighter. But you get the idea. So, you know, RockSim and Roxim Pro are really good at allowing you to do these types of experiments. You just have to, when you do these experiments, you have to control the variables. You can only control, you know, ideally only one variable should change at a time. We actually changed two variables. One was the span of the fin, and the other one was the mass, because when we changed the span of the fin, we actually reduced the mass. So to make sure that it's only one variable that changed, we should actually add mass back into the rocket to account for the mass that we took off. That's how you can make an apples to apples comparison. So I hope that answered your question, Carlos. Johan says, it's a mechanical electrical device. Yes, accelerometers are electromechanical devices. There is something inside that has to move. It has to deflect so that it can measure the strain. So basically when something deflects, it's elongating it on one side. So, you know, when you push down on a beam, the beam gets longer on the top and shorter on the bottom. So the bottom is compression, the top is in tension. And if you put strain gauges on there, you can measure how much longer the beam got on top. And from that, you can figure out how far it deflected. And from how far it deflected, you can figure out the acceleration, the amount of force it took to deflect it. And that's how they figure out acceleration. And so it is an electromechanical device. There is something in there. It's so tiny that it's just incredible that they can do this with something so small. But they do it. To Explore is here, and he is in Florida right now, but he resides in Michigan during the summers. I think he says summers. That's cool. My daughter lives in Florida. I used to live in Florida. I love Florida. Oh, he says to explore. He says it was summers, not simmers. He says, to explore, is the engine loading feature available in RockSim version 10? And the answer to that is no, it's not in version 10. It's a new feature that will be available in version 11. When is version 11 coming out? Soon. I don't know. I don't have an exact date yet because we still have the finishing touches to put on. Plus, we have to fix our website to try to automate the order process so that it's easier, because we're not only selling the full version, we're also selling an upgrade version. And so there's a lot of people that have the upgrade, and we want to make it as easy as possible for those people to migrate over to 11 from version 10. What's probably going to happen first is Roxim Pro will be released first. Roxim Pro is a subscription model. So people that have version 3, Roxim Pro 3, will get version 4 for the same price because they're just paying month by month. And we don't have to do anything for those people. It's just They download it and start using it. It's for version 11. So there's RockSim and Roxim Pro. RockSim is 3 degrees of freedom. Roxim Pro is 6 degrees of freedom. And it has that 3-dimensional screen that I just showed you where you can see the trajectory in 3 dimensions, and you can rotate it and look at it from any direction you want on the Earth. That's in Pro. So that's the one we're going to release first, and then RockSim 11. Terry says, do we have to manually enter PVC SRMs into the engine database? I am not sure what a PVC SRM is, but the answer is probably yes. Wait, he says, zoom out to space. Are you seeing the ablate is round, not flat? Yes, the Earth is round. In Roxim Pro, we only have maps for the land area. We don't have maps for the ocean because the ocean is pretty boring because it all looks alike. So if I zoom out, which I'm doing now, you'll see the land. You can see the mountains. And, you know, if I keep zooming out, there's the Earth. But all this black here is water. And it all looks the same. It's only the Earth, you know, the actual solid stuff that has any interest to us. So there's maps that go on the terrain. So there's the Earth, and then there's the terrain, and then on top of the terrain are the maps. And right now the maps are not loading. And like I said, our programmers are working on that, and they said they were working on it today. I thought they had it fixed, but apparently not. Not totally fixed. Dave says, people in Florida simmer in the summer. Oh, Dave. Chris's Rocketry and More says, is there going to be a charge for the upgrade to 11? And the answer, Chris, is unfortunately yes. The history of this is the last time we had an upgrade fee from one version to the next was from version 8 to version 9. So the last time that we asked people to pay an upgrade fee, let me go back here to the Apogee website. You go to how-to and guides, software, and version history. And if I go back to version 9 right here, I can tell you when it was released as soon as it loads the page. Okay, it was released in 2008. That's 12 years ago. That's the last time, if you had version 8 and you paid for version 8, that was, or version 9, in 2008, that was the last time you had to pay us any money. And since then, we released version 9, and we released, let's see, the last version of 9 was 9.6.3. So what that means is the first one is the major version. The second number is the number of feature enhancement versions. And then the last digit here is the bug fixes in that particular version. So we did 9 upgrades, or 6 upgrades to version 9, and then we released version 10, and there wasn't an upgrade fee for that one either. And since version 10 was released, and that one was released in 2000, so that was 4 years ago, in the last 4 years, we did 5 feature enhancements, and you can see all the features that we added, all the new things that we added into version 10. And the last one was on November 22, or October 11 of 22. That was the last one that we released. We haven't done any bug fixes since then because basically that one, we nailed all the bugs down. We knocked them down. And so after that, then we started working on version 11. And version 11 is going to have these major features, but there's going to be an upgrade fee. We're trying to make it as small as possible, but I have to pay the programmers, and they're not cheap. So there will be an upgrade fee. But I don't know what it is yet, and I don't know when the release date is yet, but it's going to be soon. As fast as we can get the website fixed. And that's, like I said, Roxim Pro will probably be released soonest. Before we can release it, we want to update some of the parts databases and our kit files, because since the last version in 2022, last year in 2023, we released 12 new kits. So we want to get all those new kits into the database. So we have little things like that we have to incorporate into Roxim 11 before we can release it. So that's the holdup. I gotta watch my time here. Okay, we got 8 minutes left. Terry Wheelock said, is there going to be an off-grid version? I will be in the desert. Well, Roxim 10 and version 11 are the same. They'll be standalone on your computer. It's Roxim Pro. In order to see the globe with the maps on it, that you have to be connected to the internet, because those are downloaded in real time. But Roxim itself will just run on your computer, and it works on Windows 11 and Macintosh. Low Budget Bob is here. Well, welcome, Low Budget Bob. Okay. Just seeing. Johan says, I like to use more than 4 fins when having heavy tails. That's a good idea. You want to make those rockets stable. I haven't seen any more questions come in. What else can I show you? What else can I show you? Here's another feature. And I've shown this one before. That's coming out in version 11 and in Roxim Pro. All the features that are in Roxim 11 will be in Roxim Pro. But then Roxim Pro, because it's 6 degrees of freedom, it has some extra features. But this one that I'm going to show you right now, it will be in Roxim 11 as well as in Roxim Pro. And that's the measure tool, and that's this little button right here on the main screen. And what it's useful for is to do quick measurements. So say, for example, you want to know how much room you have in your rocket for your parachute. Or maybe your rocket has a payload bay, and you want to measure how long that payload bay is. So you can just click on the measure tool, you select the starting point and then the ending point, and it'll tell you the distance between that point and that point. In this case here, I probably want to go from the base of the shoulder to the forward centering ring of the motor mount. And so it's approximately 8.7 inches. So if my parachute is going to take up more than 8.7 inches, I might want to know about it. Or if like I said, if you have a payload bay, our nose cone E-bay, I can measure, say, okay, I know it's going to start there and it's going to extend into the nose cone about that much, so that's going to be 2.49 inches. So as long as my board is smaller than 2.49 inches, it will probably fit in that allotted space. So that's a nice little tool to have just to do quick measurement. You can click anywhere on the drawing. You can click from that fin to, the launch log right there. I don't know why you'd need that measurement, But if you needed it, you could get it that quick. So that's a cool little feature that is also coming. Yeah, there's all kinds of cool things in this new version. It's exciting. But the big one was automatic engine updates so that your engine database is always up to date, and you never have to worry about trying to load motors in. It's cool. It's very cool. I got no more questions. We still got a couple minutes, but since nobody has any questions, I think I'll throw the groundhog back up. Happy Groundhog's Day, everybody. So yes, we will be back next week, Friday. And I should be here. I'm not planning on going anywhere. Yep, same time, same station. Bring your questions on RockSim, Roxim Pro, or the Launch Visualizer. We'll try to get those answered for you. Yes, like our goal is to make you have more fun by being more successful designing rockets, flying rockets, recovering your rockets, all around more fun. So thank you for being here. I think we're going to end the broadcast in 5, 4, 3, 2, 1.